Hi, welcome to my workshop. I'm going to give you a little demonstration of what it means to be a controlled experiment. Now, we've already learned a bit about the scientific method. You have the different steps of the scientific method. And an experiment, pretty much any kind of collecting of data could be considered an experiment. But there's a particular way to go about setting up a kind of an experiment where if you want to test the effect of something on something else, whether the effect of it is, you set up a controlled experiment. And what that means really is just you're giving it something to compare with. Here it is with it, and here it is without it. And so here's my favorite example of trying to explain a controlled experiment. When I was about your age, it was kind of you'd hear it on the TV and in magazines. If you talk to your plants, they'll grow better. And that was kind of a widely discussed sort of thing. And people were like, well, I heard on TV that if you talk to your plants, they grow better. Well, suppose you wanted to test to see if that's true. And I actually remember hearing somebody do this. They go, I talked to my plant and it grew really good. That proves it. Does that prove it? Well, what if you get to your plant and you go, oh, hi, how you doing? And every day you talk to it and it grows really thick and lush. Does that prove that talking to it caused it to grow thick and lush? No, it might have grown that anyway. How do you know that talking to it had anything to do with it? So what you need to do then is to compare where one you talk to and say the other you don't. Now, let's say it's even beyond that. Some people are going, well, maybe it isn't just talking to it, but it's when you talk nice to it. They detect your psychic vibes. Anyway, so if you talk nice to it, it'll grow good. And so let's come up with an experiment. We'll take plant, we'll talk nice to it, and we'll get another one and talk mean to it. Then we can compare, right? That's what you're doing, is you're comparing to see that one variable, right? If it has an effect. Now, since we're doing an experiment, let's put on the eye protection. And, okay, so I got the one plant right here. Let's put it over here. Yeah. And let's, make sure it's in nice light situation. Yeah, that's a really nice. Oh, and make sure it has plenty of soil. We got the soil and maybe some water in it. Yeah, okay. Oh, this is good. Yeah, we'll talk to it. And we'll get another one so we can compare. And we'll put it over here. And yeah, it's like, so this one is like, oh, you're so nice. What a great, I love this shade of green. And this one, you call that green? Put you over here away from the water. Oh, you're great. I'm going to give you plenty of water. Are you thirsty? Oh, okay. Yeah, this one here. Now, if it turns out that this one grows better than that one, did I prove? I just proved it, right? I had one of them that I talked to nice, one I talked to mean. Oh, you are a terrible plant. And this one grew nice and big and lush. And this one all stilted and deformed. So did I just prove that talking to it makes it grow better? There's the question. And what is the answer? Did I just prove that? Yes or no? You are correct. The answer is no. I did not prove it. Why not? Because this one has different conditions than this one. This one has a lot of other variables that might affect how it grows that are different from this one. So how do you know what caused it to grow better, right? So this one, for example, what's one of the variables that's different? Yes, it's in a bigger pot. So a bigger pot, and with more soil that gives more area for the root mass, maybe that's what makes the difference rather than talking to it. So in order to do a controlled experiment, it has to what? It has to have the same size pot, because then you're eliminating that other variable and you want them to be the same. That's called the controlled variables that are the same. What's another thing that's different? Yeah, you're right. You got that one. The light's over on this side. It's in much better light than way over here. And so the lighting is different. So therefore, maybe it's the light that caused it to grow all thick and lush and beautiful, not the talking to. So how do you know if it was the talking to? You have to make sure that they're given exactly the same lighting, where you put them right where the same distance and all that kind of stuff. Other things, like maybe it's the temperature that makes the difference. So, you put them in a similar room with temperature. Maybe it's, well, look at the plants. You started out with this all crummy plant. You started out with a really nice plant. Maybe it would have grown thicker and lusher because this one was already sickly and bad. This one here, what else happened? Oh, that's right. I gave this one water and that one, not so much. So the point is, there's a lot of different factors here, a lot of different variables involved that might affect how well it grows. So if you do a comparison like that, it's not a fair test. This one grew well, this one grew crummy, and you can't conclude that it was because of the way I talked to it at all. Because it might have been the light, might have been the water, might have been the soil, might have been the pot that it's in, might have been the room temperature in that location. So if you really want to find out if talking to it makes a difference, you have to grow them under identical conditions. Everything has to be the same except the thing that you're testing, right? That's called the manipulated variable. The thing you're manipulating that's different, that you're trying to find out if it has an effect. If the other variable, in this case, would be the growth of the plant, which might be measured by height or number of leaves or however you want to count it and quantify it, that would be the responding variable to see how it responds, right? So you have one thing you're testing, one thing you're measuring, that's the manipulated variable, the responding variable, and all the other situations are called controlled variables. You have to control them to be the same, okay? And so what do we need to do here to make it a controlled experiment? We have to have the same what? The same what? The same what? The same, I want you right now, come up with 4 things that have to be the same and write it down in your notes. Write it down. Think about it and write it down. 1, 2, 3, 4. Okay? Now the truth is, in any situation, there's really thousands and thousands of controlled variables. Things like the same gravitational field on the Earth. That would be a controlled variable, even though it just kind of automatically takes care of itself, unless you were doing one on the moon and one on Earth. So, what you got to do a controlled experiment, you can't start out with a big old pot with a lot more soil, with a lot healthier plant. You got to start out where you've got 2 plants in identical situation, right? And so here we got 2 plants that are identical. The same what? That's right. The same kind of plant, the same health of the plant to start with, the same amount of soil, the same kind of pot, the same amount of what? Watering, okay, and the same amount of what? Light, and so they got to be exactly the same in order to compare whether or not talking to it has an effect. Then, when you do get it to sit, when you do get all the conditions the same, and you talk nice to this one, and you talk mean to this one, if they grow differently, maybe it's because of the way you talk to it. But I'll tell you what, there's actually a little bit more to it. You can't just do it once. Because how do you know that this one wouldn't have grown better anyway, right? So what you have to do is you get the more trials you have, it's sometimes called sample size. The more you sample. So if you not just have 1 of each plant, but have, say, 10 of each plant, and that would help equalize things that are unknown variables. Things like maybe the roots were already more well developed, or maybe there was a bug in this one and not in that one. Things that you can't necessarily account for. What you do is you have a whole bunch of them, and then they're evenly distributed, so that will tend to even out any of those unknown variables. Now, there's something even more important, or along the same lines, is you also can't go, oh, I like this one, I want to put it in the talking group. Oh, I like this one, I don't like this one, I want to put it over in the talking mean group. You can't pick and choose like that, right? It's got to be random sampling, because otherwise you might be, without even realizing it, you might be choosing the ones that are going to grow better anyway. Maybe you're choosing it based on the color. It's just what appeals to you. But that's going to give it an advantage, an unfair advantage. So what you're trying to do is a fair test where you can compare 2 equal situations where everything is identical except the thing you're trying to test. Then, if the 10 that you have that were randomly selected grow significantly better than the other ones, then you could conclude that how you talk to it made it grow better. But unless you do that, you just never know if that's the case. Now, I don't know whether you think talking to it would make it grow better or not. Uh, Probably not, but whatever. I never really actually did the experiment. But there's a lot of other things that they've done experiments like this, like testing fertilizer, right? If you put fertilizer in this one and not in that one, you can see how it compares, how it grows. That's how they discover what fertilizers work, right? This is really important. In medicine, to test whether or not somebody, a headache remedy helps, you have people that say, okay, here, you take the headache pill. And people are like, oh wow, I think I feel better. But there's this thing called placebo effect. Sometimes just thinking you've got a pill will help make you psychologically make you feel better, especially if it's something as subjective as self-reported headache. So what they have to do is give a placebo to the other group. I mean, a placebo is one that doesn't have the medicine in it. It's a pill. So both groups get a pill, right? And that way you can equalize for the people just thinking they're going to get better because they got a pill and they believe it, and makes, the placebo effect is very, very real. Now, this is the super important kind of thing with any kind of medical research. I'll tell you what, it's super important. Right now we're having the COVID pandemic and that kind of stuff. Trying to find medications, they got to do random controlled trials, right? Where they give a certain amount of people a certain medication and others sort of get a placebo to compare whether it actually helps. Okay, and so this in medical research depends on this controlled studies, and so does a lot of different things. Learning and science. The controlled experiment is developing a fair test where all the variables are identical except the thing you're testing. Only one variable changes. That's a controlled experiment.